Howdy, howdy, this is Mr. Potter, and welcome to day 14 of our logic curriculum. Today we're going to be talking about two topics, predicate statements and quantified logic. And so I'm going to start today's lesson by talking about what I mean by a predicate statement. So I've got three sentences up here, these first three sentences. Garfield is a cat, Fluffy is a cat, Mr. Whiskers is a cat. And all of these three sentences have something in common. The part is a cat. What's different about each of these is the subject of the sentence, Garfield, Fluffy, and Mr. Whiskers. The part of the sentence that's the same, is a cat, is the predicate of the sentence. And so what I can do is I can let a capital letter C represent that predicate, is a cat. And so when I'm talking about Garfield is a cat, I can represent that by the capital letter C, which is a cat, followed by the subject, Garfield. Similarly, I can represent Fluffy as a cat by using capital C and Fluffy. Or I can say Mr. Whiskers is a cat by using capital C and Mr. Whiskers. So I can represent these statements that all have the same predicate by just mentioning the predicate as a letter followed by the subject. See Garfield for Garfield is a cat. See Mr. Whiskers for Mr. Whiskers is a cat. I can refer to any subject. So I can also refer to some generalized X, some unknown subject. If I wanted to say X is a cat, I would just say see X. I can also deal with negated statements. Notice that I have Fido is not a cat. I clearly could write the predicate for Fido is a cat, see Fido. And if I wanted the negation of that, all I'd do is I'd put a negation in there. So similarly, I could say see Snoopy and negate that statement. So I've got this concept of a predicate statement. So let's go through some more examples of this. So all of these have the same predicate, is a whole number. So I'm going to let the capital letter W represent the predicate is a whole number. So if I wanted to say 2 is a whole number, I would just say W2. If I wanted to say 0 is a whole number, I would say W0. And similarly, I could do W573 or WX if I wanted to say the variable X is a whole number. And there are numbers that are not whole numbers. So for example, 0.3 is not a whole number. Or 1/2, which is not a whole number. These are examples of predicate statements. What we're going to be doing is we're going to be taking these predicate statements and just talking about what they mean in different contexts. So if I let J be the predicate knows logic, if I put J Mary, that's really the sentence Mary knows logic. If I have the predicate J Fred, I'm really saying that Fred knows logic. And if I have the predicate negation J Mr. Potter, I'm really saying that Mr. Potter doesn't know logic. So I can go back and forth. I can be given a sentence and come up with the predicate symbols, or I can be given the predicate symbols and come up with these sentences, these statements. The second thing that we're going to be talking about today are quantified statements. Quantified means that we're dealing with some quantity, how much. And in the context of what we're going to be talking about, how much is either everything, universal, all things, or some things, existential, some. And so I can talk about all the things, or I can talk about some of the things. If I wanted to talk about no thing or none of the things, none would really be universal in addition to all. It's kind of like all of nothing, so that's none. So I've got this all, some, or none idea with these universal or existential quantified statements. The symbol for a universal is an upside down A. And the symbol for an existential is a backward Z. And so these are terms that we're going to see when we try and write sentences as universal sentences or existential sentences. And we'll be talking more about how we'll use these in the next lesson. So let's say I have the sentence, all dogs have fleas. What I'm really saying is if X is a dog, then X has fleas. For all the dogs in the world, I can imagine myself crossing the continents, looking for dogs, picking up dogs, checking each of them to see if they have fleas. And if every dog that I pick up also has fleas, then I can say all dogs has fleas. And so for us, when we're writing this as a universal for all dogs, if X is a dog, that's the predicate dx, then X has fleas, that's the predicate fx. So my universal statements have to use this upside down A, but my universal statements are also going to be conditional statements. They're going to be if-then statements. Now, for quantified statements, we don't actually say if and then. We just use the symbols, and we'll talk more about how we use those symbols in our next lesson. But if I have some dogs have fleas, what I'm doing is I'm going around the world and I found at least one dog, maybe 2, maybe 10, maybe 30,000 dogs. But it is a dog and it has fleas. So I'm saying that there exists at least one dog, the existential, that it is a dog and X has fleas. So whenever we're using a universals always use conditionals. Universals always use conditionals. Existentials always use conjunctions. Those are always the symbols that we're going to be using when we're talking about these quantified statements. Whenever I'm talking about all, I'm going to be using a conditional for the predicates. And whenever I'm talking about some, I'm going to be using a conjunction with the predicates. So in this situation, if I wanted to say that no dogs have fleas, what I'm really saying is I've checked every dog in the world and none of them have fleas. But as I'm going around the world, I am looking at dogs. So this statement dx is not negated. I'm not saying they're not dogs. What I'm actually saying is that they don't have fleas. Negation fx. And so for this universal, and it's universal because I'm saying all the dogs don't have fleas, I'm saying that they are dogs, they just don't have fleas. And similarly down here where I have not all dogs have fleas, that means I've gone around the world and I found at least one dog that doesn't have fleas. So what I can say is I can say existential X. It is a dog and it doesn't have fleas. What's important to know is these situations where I'm dealing with nots and no's. I'm dealing with negations, but the negation is always on the second predicate. It's never on the first predicate. It's always on the second predicate. I'm saying that they're dogs, they don't have fleas. They are dogs, they don't have fleas. My negation is always on the second predicate. So let's go through some more examples here. Here I've got all cats have whiskers. So first, I need to set up my predicates. There's two main ideas here. I've got this concept of being a cat, and I've got the concept of having whiskers. Remember that a all represents a universal, And universals are always going to be conditionals. So I'm going to have C, X, and W, X. I have no idea which cat I'm talking about, so I have to talk about the general X cat. Similarly, when I'm talking about sum is my existential, and existentials are always going to be conjunctions. But I'm saying it is a cat and it has whiskers. If I say no cats have whiskers, that is a universal. Remember that universals always use conditionals, and whenever I have a negation, it's always my second predicate that's negated. I'm not saying that it's not a cat. I'm saying that it doesn't have whiskers. And then I've got my fourth statement here. Not all cats have whiskers. This is existential. I'm saying that they are a cat and they don't have whiskers. So what we need to get comfortable with is if I have symbols, how do I write the sentence? And if I have sentences, how do I express it using the symbols for quantified statements and for predicates? Oftentimes we have to come up with these predicates first, and then we have to determine, are we dealing with a universal or an existential situation? And we have to use the key symbols that go with those terms. So once again, this is Mr. Potter with Logic. I appreciate your watching. Have a good day.